So now that we've seen what Newton's first law says, let us look at the mathematical form of Newton's first law. So first of all, let us see. So the Newton's first law talks about force and the effect of force on any particular object. So here, for instance, I have a glass bowl and I'm going to use this as my object. So this is my system and I'm going to exert a force using my hand through this rubber onto this. So I'll just quickly attach the rubber to this. Okay, so now what I'm going to do is I'm going to look at what are the factors on which the effect of force is dependent on. So firstly, what is the effect of force? So we had seen that if an object was at rest and you applied a force on it, like a pull or even a push, any of it, the object gained speed. So it was set in motion, and if I kept on applying the force, so here let us assume that the force I apply is greater than the force of friction, and if I continue to apply that force, I will keep on increasing the speed of the object. So the object will keep on accelerating, right? So first it was stationary, which means its speed was 0 meters per second, but soon its speed increased to some number, and as I kept on applying force, it went faster and faster. So that in terms of physics is called acceleration. So the effect of force is acceleration. Remember, the effect of force is not motion, but the effect of force is acceleration. If I had said the effect of force is motion, that meant that applying force, you simply get any type of motion. But here I am specifying that when I apply some force, to be precise, when I apply some external from the outside unbalanced force, by unbalanced I mean my force is not being cancelled by friction. So in this case it is perfectly balanced, but if I increase the force, I am applying an unbalanced force. So if I apply an external unbalanced force, we've seen why external and unbalanced force are required, we get some acceleration. Or if the object is already in motion, I can apply force like the force of friction, which can decelerate the object. So the object is moving with some velocity, and the force of friction will slow it down, decelerate it, negative acceleration. So the effect of, in simpler terms, the effect of force is either acceleration or deceleration. Or to be more concise actually, I can say that the effect of force is acceleration. Now on what does this effect depend? Or in other words, how do we know by applying, let's say, 2 units of force, how much acceleration do I get? So to get a mathematical relation, we need to see on what all does this relation of force and acceleration depend on. So to start off with, one relation that I can simply write down is that force is proportional to acceleration, actually I should frame it this way: acceleration is proportional to force. If I write that on paper, I get, so I can write acceleration denoted by an A is proportional to force. This here simply means that the more force I apply, the more acceleration I get, which is very clear here, because if I apply a slight bit of force, I get a very small acceleration. On the other hand, so I don't want to break this bowl, but if I apply a large amount of force, I get a very high acceleration, right? See, I'm applying a lot of force and I get a high acceleration. So the more the acceleration I have, the force I have, the more acceleration I get. So acceleration is proportional to force. So I've seen that force and acceleration are related. In fact, they are directly proportional to each other. Now, how exactly are they related? In other words, if I apply, let's say, 14 units of force, how much acceleration do I get? So acceleration is actually dependent on one more thing, or let's say force is also dependent on one more thing. So let's say I keep my acceleration constant. Let's say I want to accelerate this object by 1 meters per second or 1 meters per second square. So how much force do I need? Well, let us find that out. So here I have this bowl, and there is some friction obviously between the bottom of the bowl and the table. let's say that is, but that is obviously constant. So I'll have to apply a force that is larger than this frictional force. Let's say I apply this much force and I get some acceleration. Okay, let's say this acceleration, I don't know what this is, but this is some acceleration, right? Now how do I know? So in this case, by applying just a small amount of force, I get this much acceleration. Now what I can do is, I have some coins in this packet, and I can put those coins inside this bowl, and by doing so, what I'm doing is I'm increasing the mass of this object. So I'll add just a few more. Yeah, sure. So that should do. Now this bowl is much heavier. Now I have done two things here. Firstly, I've increased the mass of this object, but obviously I have increased the friction by a little bit. But because this glass is pretty smooth and the table is also pretty smooth, the change in friction is not so much. So I'll assume that the friction is still the same, and the only thing that have changed is the mass of the object, and I hope the resistive forces are the same. But in this case, if you notice, I have to apply a larger force to get the same acceleration. And how do you can see that larger force? So I'm using this rubber here, so you can see the amount of stretch that I get on the rubber. In the previous case, the rubber was not getting stretched, but see, I have to apply, when I apply the force, I have to apply a larger force, and that is seen by this rubber being stretched here. And when I apply that large amount of force, only then I get that almost same acceleration. So what I see is, it takes a larger amount of force, which is seen here, to accelerate a heavier object by the same acceleration. So if I have to accelerate, let's say, a heavier object like this by 1 meters per second, and on the other hand I had this empty bowl, okay, both had the same resistive forces, let's ignore that, but to accelerate both the empty bowl and a heavier bowl which is filled with coins, to accelerate both with the same acceleration, let's say 1 meters per second square, I will need a larger force to accelerate the heavier bowl. And that is also a very intuitive idea. Why? Let's say you have a, so imagine, so because if we talk something about trucks or cars, there we have a lot of friction. So let us consider a ship in an ocean. So if you have a large ship, let's say a ship of similar to Titanic, let's say, and on the other hand you have a smaller lifeboat, a small boat, and both of them are in the same ocean, and because they are on water, they have almost negligible resistive forces, so the friction there is negligible. And in that case, if you imagine pushing on one hand Titanic and on the other hand pushing a small lifeboat, you can obviously guess that it is much harder to accelerate Titanic, while it is much simpler to accelerate that small lifeboat. So you can obviously push the lifeboat very easily, but on the other hand, so you might have also seen the engines on both the ships, on the ship and the small boat. On the small boat, you need a very small rotor blade on the bottom, and that is not a very powerful motor, but that is enough to push and accelerate the boat with the decent acceleration. But on the other hand, to accelerate a large ship like Titanic, you need a very large and a very powerful motor to accelerate that large ship with the same acceleration. So what we get from this simple demonstration is that it takes more force to accelerate a heavier object. And this is very simple to try at your homes also. You can try and do this demonstration at your home and feel that, yeah, I need a larger force to accelerate this as compared to a smaller force to accelerate this by the same amount. And that seems pretty logical, and I can use this, now let me just put that on paper. So we had seen that acceleration is proportional to force, which means that to get a larger acceleration, I need a larger force. I can also write this as force is proportional to acceleration. I have just flipped the two, and what this means is that to get a larger acceleration I need a larger force, to get a smaller acceleration I need a smaller force. Obviously this one makes more intuitive sense, but just for the sake of this relation I'm writing it this way. Also we just saw that force is proportional to mass. So this simply means that to accelerate a lighter mass by some acceleration I need a smaller force, and to accelerate a heavier object that has a larger mass by the same acceleration I need a larger force. So therefore force is proportional to the mass of the object. Now I can combine these two facts, this and this, in one equation by writing force equals mass times acceleration. So this means that if I have to, let's say, accelerate a mass of 1 kg by, let's say, 1 meter per second, so what I do is 1 kg into 1 meter per second square actually. So I'm accelerating a mass of 1 kg with an acceleration of 1 meters per second. So every second I'm gaining 1 meter per second of velocity. So to do this I need 1 unit of force. So what I can do is I can solve this to get the units of force. So 1 unit of force. How much is 1 unit? Let me just solve this, and I get 1 unit of force is 1 into 1 is simply 1, and I get kg times meter per second square. So this is the unit of force, kg meter per second square, and because this was a very big unit, so to make things simpler, what we do is we use another unit for this which is exactly equal to this, but we use a shorter unit. And because the first law of motion was given by Sir Isaac Newton, so therefore in his honor we call the unit of force, well, Newton. Newton, 1 Newton. So how much is 1 Newton? So to define it, to define 1 Newton, I may say that when we are accelerating a mass of 1 kg by an acceleration of 1 meters per second square, I need to apply a force of 1 Newton. So that force that is required to accelerate 1 kg mass by 1 meters per second of acceleration is 1 Newton. Or in other words, we may also say that that force is 1 kg meter per second square, and you may write that as 1 Newton, or in short simply 1 capital N. Capital N because Newton was a human being. So that is it for this video, and I hope you understood what is the relation between force and acceleration, and how force is proportional to both mass and force is proportional to acceleration, and what is 1 Newton and what is 1 Newton of force.